All right, in this video, I'm going to be going over the question number 3 on the free response questions. And essentially, hopefully, you've already watched the first 2 questions. And this last one is going to be about a company acquired the rights to use a forest, and they're going to harvest the trees to produce lumber. The interesting thing about this land that they purchased is that there are lots of different trees out there in terms of some are old and much larger and some are younger and much smaller. So they've come up with this idea for how they want to basically figure out the diameters, sizes of these trees. All right, so they've given you some information about the plots. You can see there are 200 plots. There's plot 6, plot 121. Plot 6 is a lot less trees, but they're much bigger. And plot 121, there are more trees, but they're smaller. All right, so we're going to first describe a procedure for how to use cluster sampling to obtain a random sample of approximately 5% of the trees from the forest using the plots as clusters. So remember cluster? Cluster is where we're going to separate into all of our groups. And in this case, we're going to separate into different plots. And then we're going to randomly select 5% of 200, which is 10 numbers. And then from there, once we randomly select 10 plots, we're going to go into those plots and measure every single tree that's in that plot. So that would be a cluster sample. All right, so what I'm going to do is I am going to number the plots 1 to 200. Each number will be on a slip of paper. Put the slips of paper into a hat. Shake the hat and pull out 10 numbers. All right, and I'll put in parentheses here, one at a time, right? Because you need to shake the hat between each time that you choose a number. All right, and then we're going to go to those 10 plots and measure every tree. All right, the diameter of each tree. So that would be a way to obtain a random sample of approximately 5% of the trees from the forest, okay, using cluster sampling. Now, part B is essentially the same thing, except instead of using cluster sampling, we have to do stratified sampling. And you can already imagine, if you know what stratified sampling is, this is going to be a much more challenging process because stratified sampling is we have to go to each single group. So in this case, each plot, and we're going to randomly sample 5% of the trees in those plots. All right. So yes, on the one hand, it will be more representative in terms of the amount of trees because we could end up in the first scenario with cluster sampling get a lot of plots that have a few number of trees, and so we may not actually get 5%. In this case, we're guaranteed to get 5% if we're going to every single plot, but that's going to come with a cost. All right, so I'm going to do in each plot I will number the trees from 1 to n, and n is just the last tree that I count in each plot. Put them on slips of paper and into a hat. Shake the hat and pull out 5% of the total, one at a time. Remember to shake the hat between each time. So again, if there are only let's see, if there's only 100 trees, then I'm only going to be pulling out 5 numbers. If there's 10 trees, I'm not even really going to be able to pull out a whole number. So yeah, I'd round up to one of them for 10%. Right? The idea is that you're only pulling out 5% of the total trees in each plot, and that's how many you're going to sample from there. All right, so the numbers you pull out are the trees you measure in that plot. And you've got to do this process for all 200 plots. And you do your best with the rounding, right? You might have a plot that has 183 trees, so you're just rounding for 5% of that. Okay, let's get into the statistical, or not I shouldn't say statistical, it could be, but just advantage or disadvantage or advantage for each of these scenarios. So the first one was cluster sampling. I think the biggest advantage for using cluster sampling is you only have to go to 10 plots, right? In this scenario, you only have to visit 10 plots, right? That's a huge advantage in terms of saving you time. Yes, you will have to measure every single tree in those 10 plots, but you only have to transport yourself to 10 different ones. In terms of D, it says an advantage of stratified. So I think if you had all the time and money in the world, D for stratified is the way to go, because as I mentioned with the cluster sampling, let's say you randomly just choose a lot of plots in the first scenario that have a lot of big older trees, or you randomly choose a lot of plots that have a lot of small younger trees, right? That's going to over or underrepresent the diameter of your trees based on what sample you end up choosing. So somebody might have a sample that has way more larger trees, when someone else might do the same thing but get a lot more younger trees, so they're smaller. So again, by doing stratified, yes, it's going to be a pain in terms of the time and the money, but it would give you a statistical advantage in terms of what you're trying to measure, which is the diameter of the trees in this land. So let's see, how do I want to say that? Using a stratified sample as opposed to a cluster sample will more likely result in a sample that is more representative of all trees. Okay, and like I said, that's a great thing in terms of your statistical advantage, but the disadvantage is it would take you a lot longer to do the stratified sample. All right, so good luck with the quizzes and the tests and all that, and make sure you're prepared for each of those.